Inspecting surfaces for defects is one of the obvious use cases for automated quality control. Because it's often difficult to catch these defects with the human eye, but to succeed with surface inspection, there are some basic things you need to get right. We'll look into them in this video. In a lacquered wood panel like this, there can be up to 25 different types of defect. Everything from pinholes, dents, orange peel, and dust in the lacquer. Needless to say, it's more than difficult for the human eye to catch and categorize all of these defects, especially when a board has a glossy surface and goes by quickly on a conveyor belt. To classify so many different defect types, we use what we call hybrid vision, a combination of traditional 2D machine vision to identify the areas on the board that might contain defects and need further investigation, and then machine learning, which based on thousands of images of good and bad products can identify and classify the defect types. But to get this far, we need to get the basics right, because inspecting surfaces can be a challenging task. One of the main things to consider is finding the right balance between, on one hand, the speed of the conveyor belt, how fast does the item pass the inspection system, and on the other hand, the material you're inspecting, the characteristics of the defects you want to find, and the amount of light you need to capture a good image. If the defects aren't too small and the item isn't too dark, you'll be able to capture images at a very high speed, sometimes up to 100 meters per minute. But say you want to detect small scratches. To find these, you need to have light coming from the sides, and this won't be as effective as when you can illuminate the board directly from above. This will then set some limitations to the speed of the conveyor belts so that you still get enough light to get the resolution you need for the image. Another thing to consider is vibrations. It's normal to have some level of vibrations coming from the production facility, and they can make it difficult to capture a usable image of the surface we want to inspect. If we're talking about high-frequency vibrations, they can cause blurriness in the image. There are two ways to solve this, either by eliminating the vibrations, by adding vibration absorbers, or by making sure that the camera is in sync with the vibrations by attaching it to the conveyor belt so they move simultaneously. The last thing I want to mention here is making sure that the surfaces you're inspecting are aligned when it comes to the distance between the surface and the camera lens. A typical scenario could be that you are inspecting items that differ in thickness. If the first board is 10 mm and the next one is 40 mm, you will suddenly have changed the working distance significantly. This will impact the image, so to prevent this, we need to keep the working distance at a constant. This can be achieved by placing the camera on an actuator that will then adjust according to the thickness of the item you're inspecting. So this was some of the fundamental factors you need to consider when doing surface inspection. If you have any questions about this, please feel free to reach out to us at JLI.